lemma we have proved a moment ago can be represented graphically this way. Suppose, for example, that there are only two goods, and tracing this graphic as in the introduction, we supposed ISO value goods, which in reality are straight lines. ISO value is nothing but P1 times X1 plus P2 times X2 equal to a constant C. By resolving this equality for X2, we obtain C on P2, or clearly if P2 is a positive number, minus P1 on P2 times X1. We obtain a straight line. The locus of all the pairs X1 and X2, which gives the same total value. So you have some lines like these. The theorem we obtained a moment ago tells us that T star belongs to the highest ISO value pool. Because it maximizes at the price system T star the total value of available resources. Is it clear? As this graphic suggests, from the lemma we can obtain in a moment the main result. In other terms, T star belongs to the transformation function on the boundary of a set T. Because if our absurd were not true, for example, T star is in this point, it would be possible to find another T in large T such that T has all the components greater or equal than T star, and T is different from T star. And this means simply that T has at least one component greater than T star. For example, point like this, in this case, both components of T are greater than T star. Is it possible? No. If the price system, the equilibrium price system, potential, has all positive components, this is not possible. Why? Clearly, because by multiplying this alternative T by P star, you would obtain a total value of available resources which is greater than the value of the equilibrium available resources T star. And this is clearly in contrast with our previous level. So if the price systems are positive, you obtain the following very, very, very important result. In equilibrium, there is technical efficiency. In other terms, the allocation of production factors is constituted a Pareto optimum for production. In other terms, it is not possible to increase the production of any good with respect to the equilibrium situation without reducing the production of another good. So the situation is that represented in this diagram, this time is on the transformation of economy. clear? Note that we obtain this important theorem as a trivial consequence of a previous level, which is based in part only on the hypothesis of maximization of profit by all firms. Convexity, returns to scale and so on, has no role in this proof. They are very important in order to prove the existence of equilibrium. But if you admit that equilibrium exists by this theorem, without any appeal to convexity and other properties of a production set, you can prove that equilibrium is technically efficient. It's a fundamental result. Only maximization of profit is necessary in this simplified context in order to obtain this efficiency result. Clearly, if there are external effects of public goods and so on, the theorem does not generally hold. It's a well-known result. For example, when the production of a good interferes with the level of production of another firm, in this case, the theorem is not necessarily verified. Generally speaking, it is not verified. But in absence of external effects and so on, the theorem holds only by maximization of profit. Is it clear? From this theorem, many other results can be obtained. Or well, if this transformation curve is differentiable, we obtain at this point tangents between the curve and the isovalue straight line. So in marginal terms, the marginal rate of transformation between our two goods must be equal to the ratio of their respective prices. A well-known result of elementary microeconomics, and so on. However, we are not interested at this point to these marginal results. But however, they are simply a consequence of a previous level. Now, we shall prove the fundamental first theorem of welfare economics. In equilibrium, there is not only an efficient allocation of factors between production sectors, but also an efficient allocation of consumption goods among households, the real Pareto optimum. There are two versions of this theorem. In the first, the more general one, we shall prove without introducing, also in this case, any particular properties of preferences or production sets, that any equilibrium allocation of consumption goods is a weak Pareto optimum for the economy. The second theorem, second version of the first theorem of welfare economics, tells us that under some conditions, in this case we must introduce some hypotheses about preferences, the equilibrium allocation is a strong Pareto optimum. Let us have another short break and then we shall prove these two versions of the first theorem.